All right, I'm going to go over it. So I would say like 75% of you got these right. So just be really careful if you're part of that 25. The first one, you had to add the 3, then divide by 2, and it isolates the e to the x. Obviously, we can't change these at the same base, so we ln both sides, and I get ln of 13 over 2. Make sure it's 13 over 2 in parentheses, then the ln, not 13 ln of 13 over ln of 2. You get 1.872. And it said to round to 3 decimal places, so you're going to make sure you go to that next step. This would be on the open-ended portion of your test, so you got to make sure that you follow the instructions. Number 2, this is 1 log on one side, so we have to convert this to exponential. This log would have 10 as its base, so then 10 goes over the other side and picks up the 2, drops this off, leaving 4x. And then 10 to the second is 100, 4x equals 100, so x equals 25. Non-calculator, okay? Then for the second one, on the left-hand side, you guys did okay. You're going to have to ln both sides because obviously we can't change the base to be the same thing. And then the exponent on the x, or on the 7 bumps forward. And I get x minus 2 times ln of 7 equals ln of 8. Divide both sides by ln 7. And I get x minus 2 equals ln of 8 over ln of 7. And then add the 2 to make it ln of 8 over ln of 7 plus 2. Type that in the calculator. And you should get 3.069 when it's rounded. All right, most amount of mistakes happened on question 4. So there's logs on either side of your equal sign, okay? On one side, there's multiple ones, so you want to condense it. When you condense and it starts as addition, we make it multiplication. Then you've got 1 log on both sides of the equal sign, so we can use the 1-to-1 to ignore the logs and set what's left equal to each other. When you distribute, and as smart as you guys are, silly mistakes happen when we distribute. When we distribute, that 5 goes to both. 5x plus 10 equals x plus 6, and then we just want to solve. So subtract the x, 4x plus 10 equals 6, subtract the 10, 4x equals negative 1, and 4x equals negative 4, and x equals negative 1. And then because our original question started with a log in it, we have to check these answers. So when I plug negative 1 up here, what am I looking for? If whatever's next to that log stays positive, so negative 1 plus 2 is positive 1, that's okay. And negative 1 plus 6 is 5, that's okay. It's not that if your answer is negative, we rule it out. It's only if when you plug it back in, it's 0 or it's negative, okay? So be careful. Some of you moved the log to the other side. Like some of you took this log and moved it over here. So it was log base 3 of 5 plus log base 3 of x plus 2 minus log base 3 of x plus 6. It would work, but you have to set it equal to 0. So then when we condense this down, I don't know that I would recommend this method, but it does work. It should be 5 times x plus 2 over x plus 6 when you condense it equals 0. Then the 3 picks up the 0. Distribute the 5. This would be 1 equals 5x plus 10 over x plus 6. And then we'd multiply by x plus 6 on both sides. And I get x plus 6 equals 5x plus 10. And then we just solve. So subtract the x. Subtract the 10. Divide by 4. And x is negative 1. So can it be done? Yes. I think that's messier than it needs to be. I would just condense it down so that there's 1 log on either side of the equal sign and then use to 1-to-1. Yep.
Can you just zoom back to the number 3?
Which one? 3? Mm-hmm. Go through expectations as far as test goes. Test is Thursday. Tomorrow we have visitors coming from from Chile. So I'm not going to be in class. I might be here like the first 10, 15 minutes so I can answer questions. But then the rest of the time I'm not going to be here. So if you've got questions, today's the day. Okay. You're going to, I put only 3-1 on here. We talked about it yesterday, but I only put 3-1 on here because the stuff from 3-1 came back in 3-4. But the rest of the stuff, the graphing of your exponential functions and the interest word problems are not on the test. Okay. So it is technically 3-2 to 3-4, but you needed 3-1 in order to do 3-4. So it is a blend of multiple choice. I think it's 7 open-ended. It's 20 questions. 20 questions. I think it's 7 open-ended calculator. And then it's the other 13 are non-calc and multiple choice. Test is Thursday. I just said I'm not going to be here tomorrow, right? All right, so then after, and obviously you have to have a calculator because you can't answer those 7 questions without them. After 3.1, which was the introduction into exponential functions, came the log stuff. So some basic rules. I'm not saying you're getting questions like these, but these will actually lead into what you would have to be answering. So what is log base 3 of 1? 0. What is log base 3 of 3? 1. What is log base 3 of 3 to the 5th? Good. What is 3 log base 3 of 4? 4. What is log base 3 of 1/3? -1. We got to move it but keep the value, right? ln of e to the 3rd? 3. And e to the ln of 4? 4. Okay? So I mean, you might get 1 easy like that, but then others, those could get built into the other skills. All right, when it comes to graphing logs, okay, you could get asked any of these questions. 1, what does the graph look like? 2, what's the vertical asymptote? What's the x-intercept? What's the domain of your log? Okay, so let's say it said f of x equals log base 4 of x minus 3. So what impacts your vertical asymptote? Good. Horizontal shift, which exists inside your parentheses, right? So if I wanted to find my vertical asymptote, I simply set my parentheses equal to 0, and I'd get x equals 3. The parent shape of a log function looks like this, okay? It's like a square root, but it finishes out on the bottom. So if I wanted to find, let's say I want to find the x-intercept, I can convert my initial log to exponential, so this becomes y, and 4 to the y equals x minus 3, x equals 4 to the y plus 3. And then I could plot my points. If I wanted to know what the graph is, I could plot all the points. If I just want to know where the x-intercept is, I plug 0 in for y. 4 to the 0 would be 1, and this would be 4. So my x-intercept would be at 4, 0. So if I knew those two things, if I knew there was a vertical asymptote at 3, and I knew I had an x-intercept at 4, and I know the parent function shape, that should be enough information to get you a graph from multiple choice, okay? If you need to plot other points, obviously you plot other points, but that alone should get you enough information. What would be the domain of this graph? Good. Starts at your vertical asymptote. It can't include it, so it gets a parentheses, and it goes to positive infinity. Range is all real numbers, okay, for every log. Questions on anything related to graphs of logs? So again, you could get asked graph, domain, vertical asymptote, x-intercept. You can cross right through ln because you're not going to graph an ln. Like it says ln, you need calculators, you can cross right through it. You're not graphing an ln. Yeah.
Can you just quickly go back up to
Okay, then came condensing and expanding. So here's a question that's condensed, you need to expand it. Here's a question that's expanded, you need to condense it. So our product rule says if it starts as a product, what does it become when we expand it? Good. It would be log of, that's when 3a plus log 3b. So when we expand, it's addition. When we divide and it starts as when it starts as a quotient, what is it when you expand? Subtraction. So this would be log base 3 of a minus log base 3 of b. And then your quizzes, which I'll hopefully get back to today. If not, I'll make sure I hand them out tomorrow, okay? The quiz, I would say, mistakes made on these expansion is if there's more than one thing in the bottom, they all get the minus. If there's more than one thing in the top, they all get the plus. And then if you are raising to a power, what do I do with that power? Good. Kick it forward. So this would be b log base 3 of a. You're going to have to do both. Expand and condense. Okay, change of base is when you've got a log that's not like your common log or your natural log, and you rewrite this in terms of common log is which one? Log base 10, right? So this would be log of 2 over log of 5. And natural log is what? ln. ln of 2 over ln of 5. All right, then we went to 3, 4, which put it all together, right? All the different kinds of solving. So you've got exponential and you've got logs. How do you know which ones you have to check? If they start with a log. So in these 4 examples, would you have to check these answers? No. Okay, they're exponential. So let's go through all the different methods. If I have 8 equals 2 to the x plus 4, what are you going to do first? Change them so they have the same base. So this would be 2 to the third equals 2 to the x plus 4. And then the bases are the same. So we use the one-to-one property to set the exponents equal to each other. And x would equal -1. So that would be on the non-calculator section. Go to the second example. What would you have to do? First, divide by 2. We want to isolate the e to the x, right? So this would be e to the x equals 11 over 2. And then what? ln both sides. So if I ln e to the x, what do I get? Good. Just x equals, and this would be ln of 11 over 2. 1.705. It's going to tell you to round to 3 decimal places. What are you going to do with that third example? 5 to the x equals 4. ln both sides. Then the x bumps forward. X times ln of 5 equals ln of 4. And divide both sides by ln of 5. X equals 0.861. Okay, then came the one that is like your factoring question, right? So I could choose to either substitute like a in for e to the x and then factor it and then plug the e to the x back in. Or if you know what you're doing with these, you can simply just set up your 2 sets of parentheses. Instead of an x in that first spot, it's going to be e to the x because e to the x times e to the x gives you e to the 2x. And then you're just looking for the factors of -10 that sum to +3, which are what? +5, right? +5, -2. And then we split and solve. So e to the x equals -5. And e to the x equals 2. And then what? ln. So I'm going to ln -5, ln e to the x, ln e to the x, ln 2. And what happens when you ln -5 in the calculator? Negative error, which means it doesn't work, okay? So I cannot ln -5. But ln of e becomes x. And then ln of e becomes x again. And this time I'm going to ln 2. And I get 0.693. Yeah. I mean, you'll just give me the answer that works. Oh. Yeah, I don't care how you show the other one. Questions on any of the exponential stuff? So you're either changing the base, so they're the same, or lning if you can't change them to be the same. Okay, then came all the log equations. So these are the ones we have to check. And my advice to you was go through your test and star your log equations so you remember to go back and check. It has to have a log and it has to have an equal sign. Like a log of an expression, we don't have to check. So equation, meaning there has to be an equal sign somewhere in there. So if you're looking at the top 3, okay, it says one option, there are top 2 questions there, is there's a single log on one side. If there's a single log on one side, then we convert to exponential. So this is similar to the one you just did on the class kick. This would be log base 10. 10 comes over and picks up the 2. And so x would be 100. And then I would check, can I plug 100 back into the x? Yes. So I keep that answer. The base on the ln, that would be log base e. So log base e of x equals 2, and then e picks up the 2. And I would do e squared in the calculator, which is 7.389. And then I'm going to check if I plug this back in, does what's next to the ln stay positive? It does, so I keep that answer. Questions on either of those? So 1 log, convert to exponential, okay? The next kind was if there's an ln or a log on both sides. So if it said log of 3x plus 2 equals log of 7 minus x, okay? If it's the same log on either side of the equal sign, then we ignore the log. We'd set 3x plus 2 equal to 7 minus x, add the x. 4x plus 2 equals 7, subtract the 2, divide by 4. And then we check. So if I plug 5/4 in with the 3x plus 2, all that's positive, so it's not a problem. If I plug 5/4 in here, basically, I don't need to know exactly what it is. I need to know is 5/4 less than 7, because then it would stay positive, and it is. So I keep that answer. Still good? Okay. Then came if there's multiple logs on one or both sides of your equal sign. So if there's multiple logs, the first thing we're going to do is condense it down. For this first example, it's a sum, which means what when I condense? Multiplication. So this is log of x times x plus 21 equals 2. And when you condense this time, you only get 1 log. So I'm going to now convert it to exponential. This would be log base 10. So the 10 picks up the 2. 10 to the second would equal, I'm going to distribute the x at the same time, so x squared plus 21x. And then this is 100. Subtract that 100, 0 equals x squared plus 21x minus 100. Are there factors of negative 100 that sum to 21?
Yeah.
What are they?
20 minus
25, right? 25 and 4. Positive 25 minus 4. And then we split and solve. X is negative 25. X is positive 4. And then what? You have to check. So if I plug the negative 25 in the place of either of those x's, I get a negative next to the log, and I have to rule it out. If this question is multiple choice and you pick both, obviously you lose all the points. You have to check. If I plug 4 in here, it's fine. If I plug 4 in here, it's fine. So that one I get to keep. All right, then moving on. Now we've got condensing, but there's a log on both sides. This time it's a minus. What do you do if it's a minus? We're going to divide. So x over x plus 2 equals log of 2. Logs on both sides, so I ignore the log. I get x over x plus 2 equals 2. Multiply both sides by x plus 2. X equals 2x plus 4. Solve for x. So negative x equals 4. X equals negative 4. Can I keep that answer? No. This would be no solution. You can't put a negative 4 in there. You can't put a negative 4 in there. Questions on that one? Okay, and then the last one. I'm condensing LNs. So on the left-hand side, the minus means division. This time I only have a log on one side, right? So what am I going to change that ln to? Log base e. The e picks up the 2. So e to the second equals x over x plus 3. I'd multiply x plus 3 on both sides. And I get e to the second times x plus 3 equals x. Now I've got an x on both sides of the equal sign. So on the left-hand side, I could write e to the second as 7.389. If you're going to round it, which is fine, you can, but you have to round it to 3 decimal places. Don't round it less than that. Now, because I have both x's on both sides, I'm going to have to distribute the 7.389. So I get 7.389x plus 7.389 times 3, 22.167 equals x. And now I want to subtract the 7.389x so that both my x's are on the same side. 22.167 equals negative 6.389x. And then I divide both sides by negative 6.389. And 22.167 divided by negative 6.389 is negative 3.4695, so it rounds to 470. Did this question start with a log? Is ln a log? Yes. So what do you have to do? Check. Can I plug that one back in? No. So this is no solution. It doesn't work. If it was positive, I could keep it. But if it's negative, it doesn't work. Questions on anything test related? Okay, so again, if you didn't submit last night's homework, that's like priority number 1. That's due tomorrow at 8 a.m., okay? And then if you did, or you have the time, my advice is to do as much of the review as you can tonight, okay? Tomorrow I'll leave you an in-class, like, quickish review, but you'll also get some time to work on. There's an extra review for you to do. There's plenty of stuff for you to practice. You want to make sure that you're confident going into Thursday.